No heteroscedasticity. This again one of the most important assumption of the classical linear regression model. See, the scedasticity is basically variance. Okay, and hetero means different variance. So no different variances for the error term. Okay, so this is the assumption of homoscedasticity, that every observation will generate an equal variance. Okay, error will generate the equal variance. So supposedly if the errors, they are actually increasing over time. Okay, so over time the errors, they are spreading out. Okay, so like this, and this is your fitted line. Well, and hence you are not generating the best estimate. Okay, so if you look at the observations which are nearer to this fitted line, these are some of the observations which are nearer to the fitted line, and well, you should notice that these observations are more informative. Okay, because they are nearer to the fitted line. Okay, so they should be given rather more weight. And these observations, there are certain observations which are far off from the fitted line, they should be given less weight. Okay, this there. So basically this is the heteroscedasticity problem. That is, the variance is increasing over time. Okay, so for example, in case if you take up an example of consumption of people and their income levels. Okay, so you'll find this that rich people, they have more variability in their consumption, while poor people, they do not have much more variability in their consumption. Well, poor people generally, they tend to spend most of their income on food and some basic necessities, while rich people, I mean, in case if you look at their consumption basket, the kind of the consumption basket they have a very variable consumption basket. So you cannot say that the variance across the observations is equal under that case. So in case of heteroscedasticity, basically variance of ui is sigma square I. Okay, remember this I. For each observation, for each error, this variance is different. For variance of u1 would be sigma square 1. Variance of u2 would be sigma square 2. But what we exactly want is the case of homoscedasticity, where variance of ui is sigma square. Okay, that is, variance of u1 is sigma square, variance of u2 is also sigma square, variance of un is also sigma square, and so on. So every error term, that is generating equal variance. Okay, we'll be talking in detail about this assumption also later on.